Hi, in this video, I will be showing you problem number 41 of chapter 14 section 7. Find the shortest distance d from the point 8, 0, negative 8 to the plane x plus y plus z equal to 8. So let's assume the point on the plane as x plus y plus z equal to 8 as x, y, z, point P, and then point Q is 8, 0, negative 8. So the distance between the 2 points P and Q, we call it D, which is square root of x minus 8 the whole square plus y minus 0 the whole square plus z plus 8 the whole square. And we want to make this one as the shortest distance, which means we are minimizing this function. Minimizing the d function is equivalent to minimizing the d square function because we can avoid the square root symbol. So we will consider the square of this distance, which is x minus 8 the whole square plus y square plus z plus 8 the whole square. Now we know that the point x, y, z lies on the plane given by x plus y plus z equal to 8. This will give us z in terms of x and y, which is 8 minus x minus y. So we can consider a function purely in terms of x, y as opposed to a function of 3 variables. That is the one we want to minimize, the distance square function, which is x minus 8 square, y square, z, which can be replaced by 8 minus x minus y, plus 8 the whole square. I am substituting for z from here. So this will be x minus 8 the whole square, plus y square, plus 16 minus x minus y the whole square. This is our function f of xy. Now, in order to minimize this, we have to first find out the critical. So this is the objective function or the function to minimize. The critical point of this is obtained by plugging in, by substituting f of x equal to 0, by setting f of x equal to 0 and fy equal to 0, which are the partial derivatives with respect to x and y, f sub x and f sub y. So partial derivative with respect to x is 2 times x minus 8 plus 2 times 16 minus x minus y times derivative of the inside, that is derivative of negative x, which will be equal to negative 1 equal to 0. So it is 2x minus 16 plus 32 minus 2x. We are multiplying by negative 2 here. So 2 times negative 1, that will be a negative 2. So it is negative 2 times 16, so negative 32. Negative 2 times negative x, that will be a positive 2x. Negative 2 times negative y, that will be a positive 2y equal to 0. So it will be 4x plus 2y minus 48 equal to 0, or 4x plus 2y equal to 48. Or 2x plus y equal to 24 if you reduce. Call it equation 1. So here we notice that the left hand side, this one is f sub x. Right. Same way we will do f sub y equal to 0. So f sub y equal to 0 will imply, so 2 times y, we are differentiating this function f of xy partially with respect to y, plus 2 times 16 minus x minus y You are differentiating partially with respect to y. The coefficient negative 1 equal to 0. We'll keep the function as is 2y, then minus 2 times 16, that will be a minus 32, minus 2 times negative x, positive 2x, minus 2 times negative y, positive 2y, equal to 0. So you get 4y plus 2x equal to 32, or 2y plus x equal to 16. That is equation 2. So now we can use the two simultaneous equations in two unknowns x and y. We can solve by eliminating one of the variables. By elimination process, we can do this computation that is shown here, and we get y equal to 8 over 3 and x equal to 32 over 3. That is the critical point. So critical point here is x, which is 32 over 3, y is 8 over 3. Now we should also justify that the problem is one of the minimum problem, because the question is the shortest distance. So we will use the second derivative test, or the D test. So we'll compute D, which is fxx, second order partial derivative with respect to x, fyy minus fxy, the whole square. So here we know already fx from this line is the left hand side is all fx. So fxx would be 4. Same way fyy would be, so it's going to be this line, which is fy, because that's what we are setting to 0. We already computed fy, that is 4y plus 2x. So fy with respect to y, that will be a 4 as well. And fxy, you are doing the partial derivative with respect to y of fx, which will be 2 from this line. So if you do the D value, which is fxx, fyy minus fxy square, we get 4 times 4 minus 2 square. So 16 minus 4, which is equal to 8, that is positive. So we got D value a positive. D value is positive. We have to find out fxx, which we already got. Fxx equal to 4, that is positive. So together, these two, the D value, which is positive, and also the second order partial derivative with respect to x, that is also positive. Together it tells us f has a local minimum at the critical point at xy, which is equal to 32 over 3, 8 over 3. So because it gives us the local minimum by the second derivative test, what we have is the shortest distance. What we have is the shortest distance corresponding to the point, critical point 32 over 3, 8 over 3. But what is the distance? Distance is square root of x minus 8 the whole square plus y square plus 16 minus x minus y the whole square. We need to plug in x equal to 32 over 3 and y equal to 8 over 3 into this. So we compute the distance which we already found earlier, x minus 8 the whole square, square root of x minus 8 the whole square plus y square plus 16 minus x minus y the whole square. We'll plug in x equal to 32 over 3 and y equal to 8 over 3 into this. Then we simplify. we get 8 over 3 times radical 3, which is nothing but 8 over radical 3. So the shortest distance between P and Q is 8 over square root of 3. Hope this video helps.